scan here of the baby. And it's thought that possibly that's why they're so interested in pregnant women that are in the water with them. It's not necessarily the only reason, you can speculate, but it's possible that they actually may be able to visualize, using ultrasound at close range anyway, the internal organs, the lungs, in this case, a baby, for example. That moves us conveniently to the most complicated system, and I really only am going to give it some sort of cursory treatment, which is vision, but also magnetoreception. In this case, we know, of course, that the most important organ is the eye, and the receptors in the retina are of two basic types. They are the so-called the rods, which are for general light and for very, very important for night vision, and there are far more of them in most other species compared to ourselves, because almost all other mammals are better at night vision than we are. And there are co-receptors, which are really daylight receptors, that depending on the species you're looking at, will be selectively able to detect different wavelengths. For example, in our case, we're talking about blue, green, and red, for example, with trichromats. The visual fields are reversed around, so what you see on the left side of your visual field is actually crossed in the optic nerves and processed by the brain in the right-hand side, and vice versa. And a huge amount of the brain is actually dedicated to sorting out vision, because, as I mentioned before, it actually has very small numbers of different receptor types. There are lots of receptors, but not many different types in the eye, so the brain has to sort it all out. And that's why you can very easily show the way that vision is processed makes loads of computational assumptions, and it does all sorts of things at the brain level to correct the way we see the world. The simplest, of course, is that in fact the image on the retina is upside down, but I'm sure none of you see me or anyone else in the room upside down. The brain turns it conveniently back up again for you. The other thing is that where the optic nerves actually come out of the eye, there's a hole in your retina, and that's your blind spot. You can demonstrate it with sophisticated ways, but you're not aware of it, and that's because the brain fills the gaps in for you. And the other thing that you can show is these vast array of visual illusions to show that the brain is trying desperately all the time to interpret what it's seeing and then coming up with a conclusion. So do you see faces, or do you see a candlestick in the middle here? This is the so-called Thatcher illusion, which is really hard to get your head around, but if you just look at these two here, Margaret Thatcher's head upside down, they look pretty similar, don't they? But in fact, if you turn them the right way up, what's happened is that Margaret Thatcher's eyes were in fact turned upside down. They were cut and pasted upside down, as was her mouth. And you can see that here, but you can't